The following video will be about something I have some knowledge of and some experience looking up before, but I can't put my finger on it, so we'll just use current data that's available. By looking up Wikipedia, Synthetic Aperture Radar, and all other information from all the way back to 1997. And fast Fourier transforms, or FFT, not NFT. Corrado Malanga, Filippo Biondi, Armando Mei, and their proprietary software. That's a big clue. That supposedly turns synthetic aperture radar, or SAR, data done either from satellites or from airplanes flying over. Which type did they prefer to use, and which one actually provides the least number of aberrations? Which one uses the most power at the target for potentially picking up something at depth underground versus, what would work best? Proof that there's a city underneath a pyramid in Egypt that I can't pronounce, but it's sometimes called the Great Pyramids or whatever, Khafre. And people keep alluding to the Halls of Amenti, or Amenti. Again, I'm not going to be able to pronounce these right. By the way, if you're not aware of it, most of the names for these things, if you're looking up historical accounts, were done by people who avoided using some sounds or implied them or didn't use vowels. So I don't feel so bad getting these wrong, but I'm sure that there's an agreed upon current pronunciation. All of this was first published in the Journal of Remote Sensing, which immediately is going to tickle someone's fancy, back in October of 2022. Synthetic Aperture Radar Doppler Tomography reveals details of undiscovered high-resolution internal structure of the Great Pyramid of Giza. If anybody's curious, these people are from a country called Italy, apparently, and that looks badly translated, but that's just far over the top. But I'll tear into that in a minute if I want to. This was published, but still has yet to be peer-reviewed. We're in 2025 and hasn't been peer-reviewed. Oh, wait a minute. We have a proprietary method. The synthetic aperture radar, or pulsed satellite radar data, or aerial flyover data, was run through proprietary software, but it's likely just fast Fourier transform techniques. The same has been used since 1997 by NASA. Now, a lot of people immediately, some people, if you're not aware of it on the internet, get immediately like the Halls of Amenti, or if you bring up the pyramids of Giza, the frontal lobe gets shut off. They don't listen. If you bring up NASA, they become either irrationally true believers or irrationally non-believers. We're going to go through this. There was a video I'll try to include a link to the video below. I have already another link for another subject, but it ends in DVM. That's not the video I'm looking up. But I just recently saw a video talking about how you can use fast Fourier transforms for n-dimension analysis. Now, if you're not aware of this will go into music theory in a minute, but we're just going to blast through this. When you scan an area with radar, different frequencies will do different things to different materials. But all of them together indicate that at higher powers, you can get extra reflections of radar data that add noise and sometimes make a completely useless scan of an area. But they rely on something pretty straightforward. The area has to be relatively flat, so that you can then mathematically just delete the ground if you're going to look under it. And it has to be relatively homogeneous. I'm going to use that wording that way and pronunciate it that way because it annoys people. What that means is it's all flat, let's say, sand. please look up the geology of the area around Giza, and is it consistent? Like, is it really consistent? Okay. The next thing is, did they build the pyramids of Giza on top of sand or on top of an underlying granite layer? The presumption here is, and this is in pop science here, not real science, is that they're on pillars that go into the ground. And then somehow they're also air shafts or water shafts, and they have spiral staircases. And every time I see it depicted, some people decide to make them into giant copper coils and, pyramid power the fuck out of everything here, which would have very different results. But anyway, this all relies on you having the least amount of noise to process so that you can immediately assume that the ground is your baseline, and based on a presumption, also underneath for X number of depth to what we would call the hard pan layer, where I grew up, it would be solid material. And it has to be relatively flat, or you have to understand it. So you have to do a pre-scan of the area so you know which layers you have, and hope you only have one or two, and either deliberately use non-ground penetrating radar because there's crap underneath that you're trying not to scan, or you use enough intensity to get through it, and the noise you're trying to delete mathematically will be the surface and anything in between it and what you're scanning, which would be to go through granite, which implies very strongly that you would be needing to hit the area with a lot of intensity, effective energy received at surface. You're not aware of the sun at miles and miles up in the air, like 50 miles or whatever, up in the stratosphere or whatever. Before the sunlight hits what we would call at least some atmosphere, it's over 1,000 watts of optical energy, literal max number. That's the biggest number over a 3 foot by 3 foot area, or 1 meter about. It's, kilowatts per meter is 1 kilowatt. It's actually a little more than that. If you're not aware of it, it has a variation of 1 or 1/2 watt over a 20-year period of time. It's so regular from the sun, it never varies more than that. Over a surface area of 1 meter at near orbit altitude, and that energy level is, the last time I checked, 1,368 watts per square meter. By the time it gets down to the Earth, it's about almost exactly 1,000 watts, because the atmosphere does stuff to absorb it. And yes, that means that the grand solar minimum and maximums do not affect the amount of energy, period, full stop, or the entire frequency range, no matter how far away or close we get to the sun, or no matter what solar cycle it is. This eliminates any argument that it's the sun because it hasn't changed wattage, because it doesn't. It doesn't change enough to be more than plus or minus 1 watt out of 1,300. But anyway, that's the effective energy. Okay. You know where we're going here. You have to hit the Earth's surface with enough radar energy to go through the claimed 2,000 feet. So what's ground penetrating radar wattage range? Well, it's measured in watts per square meter or watts per square centimeter. So Malanga, Biondi, and me, or Mei, have to state what is the wattage level at surface that hit, so we know it could go down deep enough to detect anything. Or do they explicitly not do that? Again, they have a proprietary software method. They're using fast Fourier transform software that's commercially available for this purpose, for things above the ground. And max depth, this is the data I found, 1 floor underneath. That's, maybe 20, let's say 50 feet. Let's do 50 feet. How does that translate to 2,000 feet? Well, they're using a special way of processing the noise data, the stuff that you eliminate by presumptive, assuming you're not going to scan too deep so you don't fuck it up. So you're going to be having this. When you do ground penetrating radar, which is usually done to find artifacts underground or maybe metal, in an area that's populated, might mess shit up. When you scan at depth, you want to be able to eliminate what you're not looking at. So what you do is you do a very shallow dive here of data, and then use that data so you can find that data again in the noise that you're creating by overloading the area, and then subtract it and mathematically check it. Now, how do you do this? Real simple. A worst case scenario that's been done is you look for landfills and mines that have been filled in that were strip mines. I'm not kidding. How do we test the procedure? Well, I have a flashlight. I'll shine it in the room. Well, it's a particular flashlight and uses an LED. Okay, we check for quality. So we put some color panels in. We do a test run. Okay. Oh, the green and yellow spectrum of the light is off a little bit. Okay. So it has a notch there. Okay, we'll make sure we compensate for that, and we'll take the data we get back and then boost the yellow or the green, and that'll compensate for the LED that I'm using that's a cheap one from the old days. Okay, let's just do that as an example. Okay, might have noticed my background here. If you use that same data for the wrong flashlight, it's not going to work, right? Okay, so, but we can do that test and find out what the limitations of our test method are. Do these three scientists have examples where they tested it on an area with a known pattern and used an identical copy of this algorithm? It's a proprietary algorithm. That means they're not going to tell you how it works, but gave the same settings. Trust us, bro. And confirmed that they could get rid of the noise and go deeper. And the other method for doing this is known areas with actual underground tunnels and underground structures, because they exist. And you can do it in an ideal situation. Flooded areas with towns at the bottom because a dam was built. An area that's been a drift mine for stuff. There's one, and I think it's Montana. It's an underground vault that gets to be in conspiracy theory people's mind. Do you scan that and detect all these voids underground and confirm you can trace it down 2,000 feet? When people have tried to do this, they get no results. It doesn't fucking do it. So they came up with the following. They came up with a new and novel method that would totally make it to where we could scan some of these underground mines, which desperately needs to be done because we don't have them mapped properly, and we need to map them because we need to be able to find out what's down there so they can be refilled or do more mining. Did they do that? No. No, the specialized reinterpretation of something that's never been able to be done before this way with this detail for 2,000 feet underground, or sometimes 4,000 is quoted, is only used in one special case. Looking underneath the pyramid and then doing a study or a work and not having it peer reviewed and then getting on the news and doing lots and lots of press meetups and pressers and blogs and vlogs and podcasts. And real science has a useful output, practical science like practical magic. We need this kind of technology to do shit like this. Like, locate stuff we might mine, locate old mines, or places where people have dumped garbage and or places where we have toxic waste that's buried by the government or nuclear waste or whatever, and we can scan these areas, right? Are they doing that? And again, I have to reemphasize, this area that they scanned has all sorts of stuff underground because it's been cyclically rebuilt over and over again with lots of layers. This kind of stuff sounds pretty ordinary, except they haven't tested this in an area that's already been dug up that they can confirm works that way and then use identical system to scan this area. Conclusion. These three Italians are wanting to be in the news and wanting people to find them impressive. This is an ego trip. Or get it peer reviewed, not have the methodology proprietary, let us examine and see under the hood. I don't trust the results, and the conclusions are fantastical at best. That's my opinion from an idiot outsider view. Thank you for watching. Have a good day. Good luck with that. And put them to work scanning stuff that would have a practical value for people right now as a test to see if they can get it right. Because some of this stuff has been mapped out underground. We know what the results should be, but that information isn't readily available to them, maybe. Double-blind testing.